Yeah, recording started. Yeah. So good evening, everyone. So today we have, on behalf of NNF Karnataka, again welcome all. And today we have really a very good session. We have a person who has worked through and through from the first version till the latest version of SLE 6000. So he knows in and out. So you can call him an encyclopedia in ventilator. We have Mr. Martin on behalf of NNF Karnataka. Warm welcome to you, Mr. Martin.
Thank you very much. I'm sure it's a lot warmer there than it is here in London.
So, to give a brief introduction about Martin, he has been in this for more than 25 years, with more than 15 of those with SLE in neonatal ventilation market. So, he has seen all the 4 generation of infant ventilators, and he has seen how things have evolved in ventilation, how meticulously things have been added to make sure that the neonatal lung to make sure that neonatal lung is gently ventilated and to make it as physiological as possible. So today we are having a session on ventilators, low cost versus high cost, high frequency ventilation with mandatory mechanical ventilation as well. So, Mr. Martin, on behalf of NNF Karnataka, again welcome, and I request you to start the session. Now, I request Mr. Abid to kindly introduce our second speaker. The second topic will be on nitric oxide system parameters and facilities to look before buying the nitric oxide equipment. So, Mr. Chandan Gupta will be introduced by Mr. Abid. Abid?
Yeah, thanks
Yeah.
a lot, Dr. Prashant. Thanks a lot, and thanks Martin for joining. So we have second speaker, Mr. Chandan Gupta. He's heading South Asia for the maternal and infant care division for GE. So again, he's having the we can say 3 generation. He's what Dr. Prashant said. He's the man behind for the maternal and infant care in India, I can say from the GE side. So welcome, Chandan, and thanks a lot for joining.
Thanks, Abid.
So
happy.
Now I request Mr. Martin to start the session. Over to you, Mr. Martin.
Thank you very much, Dr. Prashant. It's a pleasure to join this session. Slightly unusual circumstances. I think for the first time in probably about 15, if not more years, it's the first time I haven't attended the annual NNF Congress, which will be sadly missed out of my annual travel itinerary. The many wonderful places I've seen in India over the years as a result of NNF conferences and the amazing changes and growth that I've seen in neonatology over the years that I've been coming to India. So we'll look ahead to 2021 perhaps, and hopefully I can catch up with old friends again at the next NNF in December 2021. Anyway, I'm calling in here from London, and which is where SLE is based, and this presentation, which fits in with the topic title, is really a short overview about the technologies of different classifications of ventilators, to allow you perhaps to have some thoughts about what's right for your practice. Now, unashamedly, I work for SLE. And as a result, nearly all the pictures I show you are going to be of SLE ventilators. I'm not attempting for this to be a sales pitch, but I'm more comfortable talking about the products I know best, and you'll see that as the presentation evolves. Okay, just move on. Okay, I don't see an SLE ventilator there at all, but I think it's fair to say that there's a lot of products in the markets now that are all very good products for for ventilation for adults, pediatric, neonatal ventilation. A vast array of them, and all of them really of good quality. So, we fit into that array. And what I'd like to take you through is some of the changes in technology that have occurred over the years that really define the different levels of ventilator that are available in the market today. So, in terms of simplicity, let's say at the entry level of the scale, the SLE 2000 is a ventilator we introduced over 20 years ago, but we still sell successfully in a number of markets around the world. So this, as you see from the monitor there, it doesn't have a lot of complexity about it, and as a user, all you need to set is the required patient pressure, the amount of oxygen, and the rate of ventilation that you require to give to that infant, along with its inspiration to expiration ratio. And you see all those settings along the top of the ventilator. What's good about this very simple ventilator is that simplicity. It only has a handful of conventional modes of ventilation, mechanical ventilation, plus a CPAP therapy. So you could use this device for non-invasive respiratory support and for invasive respiratory support. And during invasive respiratory support, you can use very simple, very basic triggering, pressure triggering, which does allow a level of synchronization between the ventilator and the baby, allowing the infant to make more determination of how frequently they breathe and how long they want to inhale for. So this type of ventilator has as you see from the bottom corner here, an integrated oxygen blender, and that delivers a very accurate oxygen air blend, which again enables you to be very comfortable about the amount of oxygen that you're giving to a patient over time. Now my presentation's disappeared. Where's that gone? Right, can you still see the presentation? Yes?
We can't see the presentation.
No, it's disappeared off the screen. I think somebody might have accidentally closed it. Just a moment.
Yeah, no problem. You need to share again.
Yeah, I'll just upload again.
Yes, we can.
It's back. It's back. Kindly unmute yourself, Martin.
There, I'm back. Okay, so that's the sort of entry level 2000. Now, what I've sort of summarized over here, this is the kind of device that would be interesting if you wanted a device with an accurate integrated oxygen blender, and you only wanted a handful of modes of ventilation to keep ventilation simple and repeatable. If your device is required to have CPAP as well as conventional ventilation, this type of device would be appropriate. Maintenance costs are very low on this kind of ventilator because the only thing that occasionally needs changing is the oxygen cell, which measures the oxygen concentration. There are no other single-use consumables per se. However, if you're looking for something more technologically advanced, such as high-frequency oscillation or a considerable battery backup or flow and volume measurements, then the 2000's not the ventilator for you. You need to start looking at greater steps in technology to be able to deliver those kind of things. If I just move on a bit, a technological step forward came a good 20 years ago with the development of these patient end flow sensors. So when I say patient end, it means that the flow sensor sits proximally to the patient, right next to the mouth on the end of the breathing circuit. These flow sensors are of a very small volume. The dead space in here is less than 1 milliliter, meaning that they're perfect for neonatal ventilation in so much that they don't trap any CO2, which could subsequently be rebreathed. The flow sensor has a piece of platinum wire inside it, which is what makes them rather expensive. And it's the platinum wire which senses very small changes in flow of gas, either into or outside the flow sensor. So this technological step allowed us to start measuring very small volumes and very small flows proximally to the patient. And these flows or changes in volume used to be measured at the ventilator, which was some great distance away from the infant. So small volumes were either missed or couldn't be measured, and breathing efforts from babies were also missed as well. So this big technological step took us into the next generation of ventilators, which can be similar to the SLE 5000. So with the ability to measure flow, we obviously have a flow signal here. So this is a technological step. Now, in respiration, why is that important, you might ask? Well, if we can see the flow, we can estimate whether our ventilation is effective or not, whether the lung is being filled up and emptied effectively and efficiently. And that's what monitoring the flow allows us to do first thing. In addition to that, you'll see all these measurements down here. We can start measuring the tidal volume that's delivered by the patient, delivered to the patient on a breath by breath basis. Or over a period of a minute, we can measure the minute ventilation. So it's giving us flow. Flow can allow us to derive the volume that's delivered to the patient. So we can really start to tune ventilation to becoming lung friendly and lung protective through control of these tidal volumes. So the rise of these of flow sensors does allow us to start controlling the amount of volume that were delivered to the patient, which is appropriate for the size of that infant and their pathology, using modes such as VTV or volume guarantee, terminologies you might be familiar with. The flow sensor also started to allow us to be much more sensitive in triggering machine breaths delivered to the patient. So you see this little green line here. When the baby's effort breaks this line, then the ventilator will deliver a supporting breath. So we adjust the green line up and down depending on how much effort we want the baby to apply to their own ventilation, or depending how big the baby is and how large that breath is likely to be. So with the flow sensor, that technology is also allowing us to trigger breaths and allowing much improved synchronization with the ventilator. You see also here the volume pressure curve. This is derived from the flow sensor data. The volume pressure curve can give us an idea of how the lungs are extending during ventilation and whether we're putting too much volume in over a period of time. The same with the flow. So the flow sensor, that one small accessory, is giving us access to a whole bunch of new things in a ventilator that weren't there previously. So if I kick on a little bit, one of those things is the ability to start maintaining a stable tidal volume. If you imagine in pressure ventilation, such as on the SLE 2000, we set a pressure and the volume that is delivered to the patient's lung is really a function of their respiratory system. If their respiratory system is quite tight, the volume is going to be quite small. If their respiratory system is fairly compliant, that volume is going to be greater. The pressure itself won't change, and you as the user won't be aware of how much volume is being delivered on a breath-by-breath basis. What the flow sensor allowed us to do was to regulate the tidal volume, and it regulates the tidal volume by automatically adjusting the pressure on each breath in order to maintain a stable tidal volume. The rough rule of thumb is 3 to 4 mils per kilogram. That is a rough rule of thumb, although that's quite universally used. But that allows us to give a good estimate, and we can put a controlled estimate into the ventilator of a safe volume that we can deliver to baby's lungs. And this has given rise to lung protective ventilation methodologies, and volume guarantee, or TTV, is really at the center of that. And that required the use of the flow sensor technology to achieve that. And the value of targeted volume and volume control in infant ventilation is quite well publicized now, to the extent that in some countries, and the UK being one of those, the use of volume guarantee ventilation is recommended by the National Institute of Clinical Excellence as the preferred method of practice in neonatal ventilation. So we bring that technology into devices such as the SLE 4000 and SLE 5000. And what you'll instantly see here is a whole bunch of new information presented on the screen, much of which is the result of having a flow sensor in place. So though you can't see them here, we're also measuring lung compliance and lung resistance on a breath-by-breath basis, which gives you a feedback idea of the health of that lung, or those lungs that are being, or those airways, I should say, that are being ventilated. This step up in flow sensor technology also brings in new modalities. So the mode pressure support ventilation, which is commonly found on many, if not nearly all, infant ventilators now, as well as adult ventilators, requires the flow sensor to be able to allow the infant to determine how frequently it wishes to breathe, and also how deeply the baby breathes. So the flow sensor determines the length of the breath, or helps to determine the length of the breath that the baby takes in pressure support ventilation. So this is a new modality that you would see in a ventilator such as the 4000 and the 5000. Within these products as well, there's a simpler, if not broader, choice of non-invasive ventilation modes. that also support the invasive modes. And additionally,
Patient record ನೋಡೋದು. ಲಾಸ್ಟ್ ಟೈಮ್ ಖಾಲಿಗೆ ಇಲ್ಲೋ ಡೈಲಿ ನೋಡೋದು. ಸೇಲ್ ಪಂಪು ಯಾವ ಮಷಿನ್ ಬಾಗ ನೋಡೋದು ಇದು ನೋಡೋದು.
and
ಇನ್ಶೂರೆನ್ಸ್ ಪೇಷಂಟ್ ಇದ್ರೆ ಅವ್ರಿಗೆಲ್ಲ ಬರೋದು ತುಂಬಿ ಕೊಡೋದು, ಕೈ ತಗೊಳ್ಳೋದು. ಸ್ಟಾಫ್ಗಳು ಲೀವ್ ಇತ್ತಂದ್ರೆ ನಿನಗೆ ಫೋನ್ ಹಚ್ಚಿ ಹೇಳ್ಬೇಕು, ಅವ್ರು ನೀ ಇನ್ನೊಬ್ರನ್ನ ಅರೇಂಜ್ ಮಾಡ್ಬೇಕು, ಯಾರು ಮಾಡ್ತೀವಿ ಎಲ್ಲದಕ್ಕೆ ಇದು ಮಾಡೋದು. ಸೊ ಟೋಟಲ್ ಕ್ಲೀನ್ ಯಾರು ಕಂಪ್ಲೇಂಟ್ ಮಾಡಿದ್ರು ಪೇಷಂಟ್ಗಳು ಸಬ್ಸ್ಕ್ರಿಪ್ಷನ್ ಆಗಲಿಲ್ಲ ಮಾಡೋದು. ಆಯಮ್ಮಗಳೆಲ್ಲ ಇದನ್ನ ಮಾಡ್ತಾರೆ.
Can you put on mute, please?
ಎಲ್ಲ ವರ್ಕ್ ಏಟಿರ್ತದೆ ನಿಮ್ ಕೆಲಸ. ಡ್ಯೂಟಿ
one second, I'm doing, sir. 1 second.
ಎಲ್ಲ ಒಂದು ಹೇಳ್ತೀವಿ, ಒಂದು 2 hours ಇರ್ತಾರೆ. 10 plus or minus 12 ಇನ್ನು ಮ್ಯಾಗ ಇರೋದಿಲ್ಲ.
Yes, done, sir.
Okay, Martin.
Okay.
Go ahead.
Okay, so at this stage of technological improvement or advance,
Martin, sorry, can you put your PPT? We can't see your PPT.
Oh, it's right here in front of me. Let me see. What can I do?
Yeah, it's coming. Yeah, go ahead.
Back again. Okay. So at the 5,000 level, new technology was introduced that allowed the delivery of high-frequency oscillation ventilation. Now, this is achieved using high-speed or very high-speed jet valves, which can deliver breaths or deliver inflations, I should say, at a rate of up to 1,200 inflations per minute. Not only that, the technology allowed us to have a reverse jet in place, which ensured that any CO2 or expired gases that were in the airways could also be expelled from the airways in high frequency oscillation. So that step up in technology was integrated into the 5,000, which brought us this type of ventilator, which gives us all the functionality of a 2,000, plus all the flow sensor technology, which gives us lung protective ventilation modes such as VTV and PSV, and also the lung protective mode of ventilation, which is high frequency oscillation ventilation. So this is a technological step forward and brings high frequency oscillation into the NICU as well. So again, I've summarized here some of the key features. These kind of ventilators usually have batteries backing them up in the event of a power outage. And in this case, we're covering a patient range up to 30 kilos from as little as just a few hundred grams for those severe preemies. Okay, so as technology has moved on, so has ventilation, and as ventilation has moved on, we're seeing more and more requirements to deliver non-invasive ventilation in favor of invasive ventilation, and in more modern ventilators, and this is the 6,000, which is a ventilator that's been around just for about 3 years now. What we're seeing, or what you'll be seeing, is a lot more non-invasive modes integrated into the ventilator with all the invasive modes, along with some other very interesting technologies which improve the quality of ventilation and the measurement of the effectiveness of ventilation. And just to home in on a few of those things, the 6,000, a main technological step was to integrate the use of devices for measuring expired CO2 in infants. And this device takes a sample proximal to the patient alongside the flow sensor, takes the sample, analyzes it in this small box here, and gives us a breath by breath understanding of the amount of carbon dioxide there is present in the exhaled breath, which in turn can give us information about the quality of the ventilation, how successful ventilation is being, if that CO2 level is kept stable and is adequate. So some centres are using end-tidal CO2 as a supporting mechanism of CO2 monitoring along with blood gas, and are able to reduce their blood gas measurements as a result of using CO2 monitoring. It doesn't replace CO2 blood gas measurements, but it's a good yardstick and an indicator of any changes that are occurring. What we've also done, or technological steps in the 6000, is that not only are these non-invasive modes there, but they're also improved to ensure that the leaks that occur in non-invasive ventilation are constantly monitored and compensated for. This means that the target pressure that you're delivering in non-invasive ventilation can always be maintained through adequate and effective leak compensation in the NIV modes of CPAP and BiPAP and even nasal high frequency oscillation. Battery technology in these devices has advanced, so you'd be getting at least 3 hours of backup comfort from a ventilator of this class, and you can connect these kinds of ventilators to the patient data management system and churn out all sorts of numbers and data for retrospective analysis. You'll see here just at the bottom, let me see, sorry, I'll come back here. No, before we go to the bottom, actually, a new feature which combines that flow sensor technology with high frequency oscillation is something that's gathering a little bit more momentum in the neonatal marketplace now, and that's volume guarantee, or VTV, in high frequency oscillation. The idea here is that in regular high frequency oscillation, the pressure waveform will fluctuate as a result of changing compliance or resistance in the patient's airways. This gives rise to some changes in the amount of CO2 that's being eliminated from the airways. So as those airways become constricted, the CO2 being eliminated from the airways decreases, and it might increase as lungs become more compliant. So using VTV with HFO is an approach which ensures that the tidal volume per breath is stabilized in high frequency oscillation, and the pressure is allowed to adjust, but keeping this this tidal volume stable. So that's an interesting idea. There's a limited amount of clinical studies that have been completed at the moment, although those that have been completed suggest there might be some interest in this for neonatology for the future. So that's combining flow sensing technology with high frequency oscillation. Okay. And I think the final sort of technological step that's worth that brings us bang up to date with what's out in the market now is that using continual SpO2 monitoring in infant ventilation, and this is the 6000 user interface. The SpO2 is constantly monitored, and the data from SpO2 is fed into the ventilator. This feeds into an algorithm called Oxygenie, and this Oxygenie algorithm makes very, very small adjustments to the oxygen blender every second in anticipation of changes in the patient's SpO2 and in response to any changes in the patient's SpO2. The algorithm results in a 27% improvement in time in target range, and this kind of technology, this closed loop oxygen technology, is something we're seeing a lot more of now in neonatology, and allows infant ventilators to automatically regulate the oxygen themselves in response to an SpO2 signal or an SpO2 change. Interestingly, through manual control on a ventilator, we can expect 40 or 50 adjustments to the blender in some cases per hour, which is rather difficult for a human being to keep up with, as is a changing SpO2. So automation of that process is a very interesting step forward, and of the papers that have been peer reviewed and published so far, the data that supports, or the data demonstrates that there's significant improvements in time in target range, and also a reduction in hyperoxia and hypoxic or severe hypoxic episodes for infants as a result of closed loop oxygen control. So that's bringing in SpO2 technology integrated into ventilators, and that's pretty much where it brings us up to date these days. So I think just one final slide that I've got here. We've almost come full loop with infant ventilation, in that CPAP is a very old methodology of respiratory support, which seemed to have been superseded by invasive ventilation sort of 20 years ago, and the instinct was to put a tube in place as quick as you can and get the ventilator going to keep infants alive. But clinical experience and time has told us that perhaps intubation can be deferred for a while whilst we try our best at non-invasive ventilation, which is why on all the latest infant ventilators, whilst they're very technologically advanced, some of the technology that they do deliver now is really a nod to what you were all doing, or perhaps doing, neonatology was doing many years ago. So things have moved on a lot, but also things have not moved on a lot at all, and relying on some of these tried and trusted methods is also an important part of the neonatal respiratory battery of skills. So I'm going to stop at that point, and I hope that the presentation was interesting and informative. And if you have any questions for me or for the chair, then please do. Thank you.
Thank you, Martin. We will take up the question at the end of second session. So now I request Mr. Chandan Gupta to start the session. Thank you. It was a wonderful presentation, Martin. I'm sure there are a lot of doubts and queries regarding the ventilatory modes and its application. So we will get back to you after this session.
All right. Okay.
Yeah. Mr. Chandan, you can start the presentation.
Yeah, I'm just trying to put my slides.
Stop sharing the slides.
Okay. So, first of all, before going to this nitric oxide system, and if Anviti or anyone, if you can put the slides. So this, I would like to just bring that what is the current status in India. And what we see is that we have, as per our estimate, around 70,000 beds for the NICUs, which is being used as of today. And out of that, what we see is that around 7,000 ventilators are being used. So it is roughly about 10% of the beds are being ventilated. Of course, there is a significant difference between, let's say, level 1, level 2 and level 3 of NICUs. In some of those NICUs, we have seen 60 to 70% of the beds are being ventilated, like level 3. At the same time, in level 1, we have seen that it's very lessly populated with the ventilator for the right reasons. Now, if you really look at even those 7,000 ventilators that is roughly in operation condition in the market, we have seen around 25% of them are having HFO. To be very honest, the actual users of the HFO may not be more than 10 and 15%, but the very reason that it is almost 25% of the population is the advent of the combo feature of the ventilator, where you can use as a very high-end ventilator and seamlessly, transform that ventilator to an HFO ventilator. So previously, when it was only an HFO ventilator, then the actual uses was significantly less and the number of HFO was significantly less. But today, because you can use the same ventilator as a very high-end ventilator, and you can move with the same circuit, you can move to the HFO, the percentage has increased significantly, and today it is more of 25%. And if you really look at the new purchases, almost like it is above 35% of the new purchases are coming up with the HFO feature. Now, if you come to the nitric oxide uses, if you look at out of those 7,000 units, to the best of our knowledge, it is less than 2%. So we are talking about around 140 to 150 units that's there in the market, which is being used for the nitric oxide. And this product is there since probably last 15-20 years. Everyone knows the benefits of the nitric oxide therapy as a vasodilator. So when everything fails, this can still give results, and for that reason, people wants to use it as a last resort. But still, there are many obstacles that we face today, and what some of those I will talk about. For that reasons, the actual uses is less than 2% of that. The most common thing that what doctors talk about is that the very reason is that this product is, first of all, is very costly. And also one is that the initial purchase price is very high. And the second thing is that if you really look at to maintain this equipment over a time, it has a lot of things that you need to change or you need to take care for the calibrations and other things. I will talk about that, for which the overall cost of ownership is very high. And it is difficult to commercially justify on or to recover that cost over a time period. So there are some innovative things that has been tried in some of those hospitals, like sharing the units with few facilities like that, or some of the cases what I have seen is that they are trying to position it that we have everything, like what you can get from us, you can trust that that's the best in the world. So that's the way to position it as a the branding, and to ensure that the patient gets the best of the care, and not to just look at the individual that equipment ROI that's being got that you get. Now, a little bit about the nitric oxide therapy. So in the nitric oxide therapy, if you see that mostly it is used in the CMB and the HFOV, there are some thought process that when you use in high frequency modes, probably the distribution is much better and efficient. You need to really look at the connections, how you are doing the connections, because if the connection goes wrong, things goes wrong abruptly. Also, you also need to ensure, because this is a specialty product and the gas is very harmful, as you know, this is being given in parts per million. The presence of a clinician is very important. For the term babies and the mostly near-term infants, what we have seen is that up to 20 ppm is what is recommended. And for the preterm, what we have seen is that we talk about to start with 5 ppm and then try to increase up to 20 ppm. And then, if you don't get result, you try to increase maximum 40 ppm. If you don't get any results for the 15 to 30 minutes, then you can stop the therapy. That's being recommended. Now, what you need to watch out whenever you are giving this nitric oxide therapy, you need to look at the methemoglobin level, and it should be less than 2%. This also affects the platelet formation and the bleeding time. So you need to watch out that one, especially for the preterm infants. Also, you need to ensure that there is a handbagging system, because while you are working with the system, for whatever reasons, if ventilator, stops, you need to have a system, because this is a very, very, toxic gas, and you cannot stop doing it while you are doing it, because it's a vasodilator. Suddenly, if you stop, there can be constrictions, and significantly the SpO2 level can fall down. So you need to ensure that you have a support system. So these are the things that you really need to look after, and you need to have a when I'm talking about to check this methemoglobin level or the platelet formation and the bleeding time, that means basically I'm saying that you need to have a mechanism to check those things while you will be administering this gas. Also, like when you will be weaning or you will be trying to remove the system, you also need to ensure that you increase the FI2, so that the vasoconstriction that will happen eventually for this removal, that's being taken care, and that also you need to ensure that you have facilities for that. As you know, this gas is, when mixes with oxygen, it creates NO2, and which is very toxic. So it is diluted in nitrogen when it's being given. But at the same time, you also need to ensure that there is a sufficient distance while you are adding this gas in this connection, which I will show, and from there to the ET tube. So approximately 20 to 25 centimeter should be there, so that it gets sufficient time to get mixed and before it reaches to the patient. So this is another thing that you need to ensure while you will be adding this. You need to ensure that this gas, the scavenging filters are being used, and when you are removing this gas, that's being done properly. Also, you also need to ensure that the gas, what the connections you're using is sampled at the patient connector, so that the patient is getting the right the portion of the NO and NO2, and that's being monitored in the main equipment. Also, for a ambient, we need to really see that it should not exceed 25 ppm for NO and 3 ppm for NO2 over an 8 hours period, so that the people who are doing this, they are not affected. You also need to ensure that it should not be coming directly to the face and the other stuffs. There is no guidelines as of today for the pregnant stuffs, or if there is any asthmatic stuff. Looks like there are no adverse effect as of today, because till now we have not seen any paper talking about that. While we talk about all these danger things, at the same time we also need to know that the traffic causes high NO2 levels, and even cigarette smoking contains up to 1000 ppm. So of course, what we have talked about are dangerous for over a period of time, but we should not be overcautious for a very small time, exposure for this. So that should not deter ourselves to use this, which is a life-saving equipment. Now, the product that we sell, we have out of this 140-50 machines that's in the market, we have around 100 machines in the market. And one of the reasons people like this, it's very easy to use. And this is a complete system. I will talk about that. And this is a very, very rugged system, and a very simple way you can attach with your existing ventilator. And it works with mainly the constant flow generator, because once you use a constant flow generator, you can ensure that the ppm are very stabilized, and that's very important, because we are talking about in ppm. Now, this is what exactly that you need to look for when you are buying a nitric oxide system, and here I have highlighted the point called system, because there are 5 different things that you need to look after. One is that the gas delivery. So you really need to look at the flow meter kind of, the way the gas is being delivered. So you really need to look at. And then the gases are being monitored so that the gas that you are giving to the patients, at what ppm you are giving, you need to monitor. Then the gas that you are adjusting through the ventilator, you need to ensure that the proper scavenging filters are there. So you are ensuring that the people around that area are not affected. At the same time, the machine should have a facility to take the sample of the ambient gases and measure that, so that over a time that exposure limit is not crossed, to ensure that the safety of the people who are doing that. And also, it should have a mechanism for whatever reason, if the ppm increases on the delivery system, it automatically it should shut down the delivery. So this is, we call, is a very important safety mechanism that should be there. As you have noticed that we have not recommended more than 20 ppm for a duration. So you need to ensure that for whatever reason the ppm increases, the machine should have a capability to know that, and immediately, apart from giving alarms, the machine should be capable of taking care and stopping the nitric oxide gas delivery. So when you will be buying that product, you need to ensure that you are buying a complete system rather than just a gas delivery or a gas monitoring system. You should be, and you should ensure that it is easy to use. At the same time, it should have all the components that you talked about. There are few things, it's a costly system. As I have said, if you see that in this system, the NO and NO2 sensors, you need to change every year. Now, these are very costly sensors. These are not like oxygen sensors. And these sensors cost around 50,000 rupees per sensor. So you can understand that that itself will be a cost of about 1 lakh rupees per year. So over a period of say 7-8 years, this is a significant cost. The second cost comes with that, the calibration. The machine, because it measures in ppm, the recommendation is that every 28 days you need to do the calibration. And in order to do the calibration kit will be given along with the system, but you need the calibration gases. Normally the calibration gases last anything between 6 to 8 months. And this you need to buy the calibration canisters, and you need to ensure that this calibration is done within every 28 days. The third component is that it requires a special circuit. Of course, we have seen in places that it's being reused, but please understand that, and this NO gases when combines with the oxygen forms NO2, and then it can make nitrous acid, and that is corrosive, and that makes holes on the circuit, and that create a lot of other problems apart from creating challenge in the ambient. So these circuits are very costly, around 6,000 rupees per circuit. So this is another component which is costly. Then the scavenging filter, which is, takes care of this all these exhaust gases. And we talk about a color change when you need to change about these scavenging filters. And this also cost around 17,000-18,000 rupees. And of course the cylinders that will be used to deliver these gases. So the very reason I wanted to highlight all this is that these are the different things that you need to consider apart from that equipment cost, and for over a time cycle that will be required while taking a decisions to buy this. But at the same time, this is a life-saving product, and this ensures in sometimes the dramatical results, and that definitely talks great about the the hospital branding and the performance level. So I just wanted to show the picture of how it looks like, the different buttons are there on the front side and also on the back side. So that, like when you talked about this ambient monitoring, how it takes the gases from the ambient, when you talk about that, you are how you're doing the printing, all these things are, you can visualize in this. And next is that how you connect it with an ventilator system. So here we have shown it with one of our HFO good high-end ventilator system called SLE 5000. And in this, if you will notice that how the gases are being added, and then how you are taking a sample, you are giving time to get the gases mixed, then you are giving a time to area where you are taking a sample to measure the NO and NO2 the concentration, and then it's being added to the humidifier, and then how it is going to the patient. So you can see this, and then after that it uses how it's being taken out through the scavenging filters from the SLA 5000, and so that you are neutralizing the overall thing. So this connection is very important. You need to ensure that the different filters that's been shown here, that's been done, because those are very important component. You need to have sufficient filters available with you, and also you need to ensure that the distance that we have mentioned, that's being properly maintained, and the connections are done properly. Like, whichever comes first needs to comes first, and like that. Last but not the least is that the availability and I have just given an example and the roughly price. The NO cylinders, and this is available in Karnataka. The NO cylinders, the empty cylinders is available at a price of around 13,000 rupees. It's about a 10-liter cylinder, 1000 ppm, and for the refilling they charges around 6,000 rupees. So plus taxes. So if complete cylinder probably will be around 20,000 rupees, and then probably subsequent refilling will be around 6,000-7,000 rupees. Of course, you can negotiate and can make it lower. And the suggestion is that because we don't want an empty cylinder during the time, so probably you need to buy 2-3 cylinders, and while depending on the uses, and then you always keep on sending one of the cylinders to the supplier so that he can refill and he can send, while you have at least 1 cylinder in uses and 1 cylinder as a standby. So recommended is to have 3 cylinders. So you need to plan that way. And similarly for the calibration cylinders, the approximate cost is around 7,500, and the suppliers is Chemix. And so far, whatever feedback that we have got from our customers is that they are good, and hope that it is meeting your requirement. So with this, I wanted to end my session. In case there are questions to Martin and me, we'll be happy to answer.
Thank you, Mr. Chandan. So before we move on to the discussion, I request Dr. Dinakar sir.
Hello.
Hello, sir. Yes, sir. Yes, sir.
Prashant, can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Yeah, please, Prashant.
Yes, sir. Regarding today's session, you are one of our panelists. So would you like to share your experience with our speakers today, and then we will start the discussion, sir.
I want to tell, yeah, I have to tell, I should not tell actually excellent, because it is more than excellent. Awesome. Very nice. Well, first, I'll just tell you, you worked hard more than 35 years. That means almost you have spent your 1/4 of your life in the taking about the SLE ventilator. Just I thought I'll ask you, and it was very excellent. You have spoke from 2000 to up to 6,000. So that means pressure control to non-invasive HFOV you spoke. It was very good. Just a few questions to you. Then I'll just go to the second speaker. Prashant, can I ask some doubts if you don't mind?
Please, sir. Go ahead, sir.
So Martin, number 1, tube leak compensation, TLC.
Yep.
Tube leak compensation, if it is there in the HFOV volume guarantee, when we set in, it will give more accurate, set that from 0.5 to almost 0.6 ml per kg. 0.6 ml per kg, because nowadays when we use HFOV, previously max to max we used to go for 12, 13, 14, 15. Now it has come down, it has increased, rate has been increased up to 20, that you know. So
okay, yeah.
Decreasing the volume up to 0.6 to 0.8 ml. So that is the newer trend in HFOV. So if there is no tube leak compensation, then achieving is very difficult.
Indeed.
In SLA 6000, tube leak tube leak compensation is there or is there in the dragger?
I think I've lost you,
Yeah.
Dr. Dinaka.
So that is there in the dragger. In SLE, tube leak compensation is there or not? I haven't seen it. Is it there? Tube leak compensation.
We don't have a function specifically called tube leak compensation. Is this something you specifically benefit from in HFO with TTV? Is that what you were saying? HFOVG?
Yeah. HFOV with volume guarantee. This bring the platinum, whatever you told that probes, whatever the sensor is there, it can up to 12, 13, 14 acceptable. But as we increase the flow, I mean frequency to 17, 18, 19, 20, because nowadays that is the trend, that is the way of treatment in HFOV. So when we do it, if there is no tube leak compensation, how we can give in HFOV volume guarantee more accurate?
Sorry. Yes, we do have a leak compensation algorithm in HFO in HFOV with VG. But what you're absolutely right, as the tidal volumes get smaller and smaller and smaller in HFO, and I think you've quoted some volumes there of less than 1 mil. The accuracy of that delivered volume becomes more and more difficult to stabilize, and this is what I think we and other manufacturers wrestle with, trying to display a meaningful average on the screen, because there's very small changes in the pressure in HFOV, tiny ones, that's micro changes. But micro changes at such small volumes make very small changes, they make significant changes to a very small volume. So stability of the actual volume at those very low volumes is difficult, even with a leak compensation algorithm.
Okay.
Yeah. So sir, I just wanted to add what Martin said. The 50%, as I remember that once we upgraded even on SLE 5000 with V5, that leak compensation was increased from 25% to 50%, and the same continued. But probably you're asking something different.
Yeah. Yes, sir. Yeah. Gupta ji, what you told is correct, because there is some terminology, almost everything is synonymous. But why we are telling is, when we have gone to some place like I think so, Martin, in your name there is one more person called Martin Klesner or Klesner. I think so. You will be knowing him.
Yes, American.
Yeah, same name. Yeah. So because he is talking about the dragger. So there is when we were discussing with him, he was telling that is very important in this. So it was not there in SLE. There was so much controversy was there, but I am using SLE since years. But I am feeling very comfortable. I have gone up to 20 and decreasing the very low volume for the less than 400, 500 gram or babies. So that is my babies are so SLE is better. Just I thought I'll ask you whether it is there or not. Why they are telling it is not there? Why it is there? Only leak compensation. Because there we can choose that up to 400 grammar or 320 grammar. Then we can enter the tube. Then automatically it will only calculate the leak, how much it is there with that. So anyhow, it is the one thing. And Martin, one more question if you don't mind. So you are telling in non-invasive ventilator, volume guarantee can we give? Is it possible in non-invasive ventilator volume? How can we do it?
Oh no, we don't have facility or we don't have capability yet to volume guarantee in non-invasive ventilation. No, it's due to the absence of the flow sensor, what we do have is leak compensation, which ensures stability of the intended CPAP pressure. So the proximal pressure is continually monitored, and the flow is regulated up and down to maintain a stable CPAP pressure. That's the leak compensation in non-invasive, which is obviously different from the leak compensation in invasive ventilation, which compensates for tidal volume. So it gets all the more confusing, I think, doesn't it, with these terminologies?
Yes, yes. And no, good explanation, because convincing. And one more thing is, in SLE 6000, in non-invasive HFOV, how how we are going to tell about? I know that it is very difficult, but approximately, but the machine will tell approximately what is the map, what is the approximate delta P. But here we are not putting any flow sensor. How we are able to get that in non-invasive HFOV map delta P? How we are going to get in the machine without flow sensor?
Yeah, so the map delta pressure are all measured with a proximal tube, which is connected to the patient manifold on the breathing circuit. So not all infant ventilators have a proximal pressure tube. SLE does. So it's it gives us a measure of the pressure right at the patient. So that gives a accurate reflection of the mean airway pressure at the manifold and the delta pressure at the patient's breathing circuit manifold as well.
Yes, yes. So I request Martin, you have worked so much. Why can't you bring out the new SLE like version 6.1, 6.2, including, it is only suggestion, and already you are giving the C20 by C, that is the whatever the compliance like DCO2, whatever it is there, how much is the expanding, even resistance you are giving. But just I am telling you, just volume is increased. Is there, okay, this is a resistive index already, or resistance is increased, so resistance it will show, machine will show. You have to bring out something like automatically if the patient improves, compliance is improving, resistance is decreasing, automatically machine only should, everything like a computer, machine only should do. It should only take care. Once we ventilate, machine only should automatically tell the patient is, everything has come, compliance is normal, resistance is normal, this is the time to go ahead and extubate. Means already artificial intelligence, can you include in your ventilator?
It's on my list, Dr. Dinniker. It sounds like a really nice idea. It's almost a map in front of you of how things are improving as time goes on, and ultimately as say 2 or 3 measures become within a target range, then that's approximate time to start thinking about extubating. I think that's what you're saying. That sounds like sounds like a very neat idea.
Yeah. When oxygen, you people have given it in the machine. When already ETCO2 is there in a conventional ventilator, in the all volume guarantee in a conventional ventilator, so you people can do something in a AI, artificial intelligence. You can add it, because that will be very good for doctors who doesn't know in a periphery. Definitely, it will be like a boon for them. Even though he can just, machine will tell, because some machine will give the, just put the weight, just put the, even body surface area is not necessary. You just put the weight and you choose the mode. It will only go to the what is it, the company factory fault setting. So at least it will try to save the baby like that mode, because I know that your competitors are having that mode. You also can accommodate, that is little 25% of AI. You can make it 100% AI incorporate.
Okay, I've made a note. It makes good sense. It makes very good sense, Dr. Dinniker. Thank you.
Thank you, Martin. I think so many people are there to ask you question. And Gupta ji, as usual, your talk is excellent, crisp, and very nice. So can I just ask you some more thing? What you can update or you can give the idea to your companies, please?
Sure, sir. I'm also getting a fan of you.
No. Somebody was telling me already only iPhone 12 is there. Dr. Dinakar is asking for iPhone 100 now only. So it's not like that. Sorry, I think so. You people are doing a great job. We are all end users, but we, always dil mange more. Our heart will ask more. Whatever you give, it is not sufficient for us. So our heart will ask more. Just
Sure.
Gupta ji, one more thing. In your inhaled nitric oxide, I am using since 2 years. I am very happy about that. But something I am not happy about your machines. So why can't you correct it? If a calibration we have to do every monthly once or 45 days once, we are doing no calibration. Really, even for the doctor, he will tend to forget to do the calibration. It is really quite stepwise method. Why can't you make? Because I have seen in abroad, your competitor brand are using automatic calibration. It will only take the calibration. I know which company I am talking about. You know it very well. Automatically, it will only calibrate because thing is connected to that. Number one, because every 35 days system will forget, or because what NO and NO2 cylinder is there, that white cylinders, what you people will give in a black bag. That one, instead of that, fix it automatically. Company every 30 days, you program it in your computer. It is very easy nowadays. Programming is very easy. So it will only take it every 30 days. So your machine will be good and the sensors will be good. Because I felt it from North Karnataka, there is one doctor, he has sent one mail to me and SMS to me, NO and NO2, this thing sensors are gone, they have charged more, but the charging will be there. I told them, sir, you have not done the, Abid, I know that which hospital doctor I'm talking. Okay.
Yeah.
So in North
Yeah.
Karnataka,
Yeah.
so that, yeah. So why can't you do that automatically? Machine will do the calibration every 30 days. It should program. Suppose if that calibration NO will be there, definitely. Only we have to give the NO2. That's it. That cylinder, instead of big cylinder, you can make it at least every year. I know that as we use every year or 1.5 year, if the sensor goes, we will replace it. It's no problem. Number one suggestion. Number two, what I am requesting Gupta ji, you are giving 2 cylinders. Your competitor cylinder people are giving 3 cylinders. That is 10 liter, 1000 ppm, 3 cylinders they are giving. In that machine, automatically, what will happen? One cylinder is getting over, other cylinder it will switch. Another cylinder it will only switch over. Suppose if at night something happens in our machine, INO, the sister will jump, then biomedical person will jump. If they don't know, then we have to come and change. In the meantime, if you know that 0.5 mm or 1 ppm, if you will change, or 2 ppm if you will change, the SpO2 might fluctuate in the PPHN case. So automatically, if it switch over, that is better. Please try to get that. Automatically, it should switch over. Giving the cylinder, no problem, 3 or 2. It should switch over. There are some competitors I saw from my eyes. And even this thing also, if you will bring it, really your machine is super. And now also it is very good. I'm not telling. What about your things? 2 questions I asked. One is about the calibration. Another is automatic switchover. Third question for you, Gupta ji. Suppose I want to connect to 5 ppm or 15 ppm, 20 ppm. I know that in the INO INOSUS, it will take minimum at least 5 minutes to 10 minutes. It is a fine tune is there more than 500, then it is 100 fine tune and rough tune is there. It will take some time. Some people might not know. Actually, it is easy. In your machine, it is easy. I'm not telling no. Instead of that, make yourself a digital one. Okay, I need 20. Just press the 20 button, up or down. Automatically, it should only set it. So if it is there, I think so your competitor people might have this. This is the three things. If it is there, very friendly INO using and these things. Gupta ji, over to you.
Yeah, so I would say the first question is something, to be honest, we also face quite regularly. And because people don't remember these 28 days and 30 days, and that really affects the performance of the machine as well. So this is something, if we can, do something, and these days it's possible to do that. If you see that if you can do oxygen, closed loop oxygen control system, those are much sophisticated. Doing this is much easier, like, so I'm sure that Martin is also there, he is also listening. And but this is a common pain point. Whatever out of the three questions, this is the most common I have heard, about 100 odd centers that where we have sold, and people forget that, and then we'll end up with so many issues. So this is something, if we can do that, it is definitely is going to help lots of clinicians, and that is going to help the machine performance as well. For the second one, because it is involved with the cylinders, I will just tell you a brief history. We used to do medical gas pipeline till 2007-8. And then we landed up with lots of issues like explosive license, certificate, and all those fire certificates, all those kind of things for all the warehouses. And because of that, we thought that because that business is such a small portion of the business, and for the whole warehousing, taking all those licenses, audits and others, it was too costly. And to be honest with you, that's the reason we decided that we will not be looking for those cylinders and the gas systems. We will have our partners, will recommend these are the companies who can supply. So what we can do is that we can actually start working with these companies like Praxair Chemics, even all these companies, and try to find out a system where it automatically changes over. For example, when you use a ventilator system with medical gas pipeline and compressor, for whatever reason the medical gas pipeline system goes off, automatically the compressor starts. It's such kind of changeover system, or whatever we see in our residences medical gas pipeline system. One cylinder goes off, the other cylinders take charge. So like that way, and it will not be very difficult, but this is a good suggestion. But we need to work. First one is that we need to work with SLE. The second one, this we need to work internally within our team in India. The third one, sorry, I forgot the question. If you just can help with the link.
Gupta ji, third one is this is like this. First one is for the calibration. You
Right.
told you are going to look into this. Second one is 2 cylinders are there. You people was getting over, automatically it should switch over to the second cylinder. That is in the second question, part A. Part B, other your competitors are telling this cylinder will come these many hours, these many minutes. It is showing digitally your competitor. So it is very algorithmically, it is simple calculation basis. But if I will tell to my postgraduates, they will remember only that, because that is a calculation. If your cylinder, B type cylinder is having this much gas, if you are giving the cylinder bleeds these many liters, so how many hours it will come? Like a nursery class, there is a formula, it will come. That same formula they have included in your software. People have included in that their software. Once we connect, first cylinder is getting over, key, alarm will come. It will switch over automatically to the second cylinder. So it will tell this cylinder will come these many hours. Suppose if you will connect to the conventional ventilator, it will tell you, because conventional ventilator 8 liter it will bleed, it will take. Suppose HFOV, sometimes it might take 15 to 20 liter. So it might get over very soon. So it is like that. Please incorporate in your machine. One is switching over, then another is how many hours the cylinder will come. Set that the doctor at least will order the nitric oxide and he will keep it ready. That is one request to you.
Sure, sir.
Third one is, make no, your competitor people are having it. I have seen in Germany. Germany machine is having, I think so, it's a European. I don't know which country. I think so. Martin will know this. Then the another third one is what I'm asking. We have to adjust in your machine 5 liter. Suppose if it is a 5 ppm, 10 ppm, 15 ppm, there is a calculation according to that we have to do it. Okay. Instead of all those calculations, why can't you put that calculation in your computer? Why can't you put that calculation in your computer? Just doctor should press, sister should press, I need 15 ppm. Doctor should order from the phone, start the nitric oxide. Definitely sister will know how to connect. When she can connect the ventilator tubing, she will connect the even nitric. She has to just press 5 or the machine should give it. Now here she won't be knowing 500 how much, then she won't be knowing the calculation. It's a tedious process. I am requesting you to do that digital way. 5 mm, it's all calculation. Just you have to put that calculation like an ultrasound machine. Calculation automatically it will only RI, PI and all. No, same thing. It's only request, Gupta ji.
No, it's a very good input. Honest, to be honest, the third one is very exciting as well, because this is so simple, because the machine already knows like what ppm we are trying to give, and what are the different flows that's coming. So depending on that, the machine should be able to do that. So I'm sure like these are very good inputs, and we'll work with Martin and to see that whether we can incorporate this in that next generation machines.
Yeah. And at the same time, giving all the ports, exhaust port and all, it is very good. And honestly, I'm telling your machines are really good, because I'm using since 2 years. So more than almost 11 patients we used. I am really happy person. Just I want, we are Indians always, dil mange more. So we are putting pressure on Gupta ji to sorry. Okay, over to Prashant.
Yes, sir. Yes, sir. Dr. Suresh has raised hand. Dr. Suresh, yeah, please.
Hi, Prashant. Hi, Dinesh. I have Dr. Ram with me also.
Hi.
So, Mr. Percy, I'd just like to say we are big fans of your ventilator. We actually just got our fourth SLA 6000 last month, and we have oxygen. We ordered oxygen for all the ventilators. We have already used one of them. We're still waiting for delivery for the other ventilators.
Lot of disturbance, Suresh. Can you speak a little louder? Lot of
Really? Can you hear me?
Yeah.
Come near to the speaker. Okay. Come near to the speaker.
Is it okay now?
Better.
Yeah, just about hear you.
Okay, let me see. Oh yeah. Is it any better now?
Yeah, better. Go ahead.
Yeah, it was using the wrong microphone from the inbuilt microphones of the external microphone. So, Mr. Percy, I don't know how much you heard of what I said, but we're big fans of your company and SLE products. We have 4 SLE ventilators and 2 of your SLE nitric oxide devices. And I have Dr. Ram here, who's a neonatologist. And so we're the first users of oxygen in India, I believe, and all our SLE 6000s have them or are in the process of getting them. They've been ordered, paid for, and ready to be delivered. Ram's got a question on SLE, the ventilator, following which I have a question on nitric oxide.
Hi, Mr. Martin.
Hi to both of you. Thank you.
Hi. Thank you very much. And as Suresh said, we have 4 SLEs, all the latest 3 are SLE 6000, and we are quite impressed with the way it works. And I have used these SLE 5000 machines when I was in the UK, and in around 2015-16, when I was working with Professor Anne Greenoff at King's College Hospital. And one morning we had lots of boxes of SLE 6000 come and land over there, and I had the first experience of SLE 6000 at King's College London, which was excellent. And so currently we have 4, and we love it, and it's been perfect. I have few questions A couple of questions basically. Number one, the flow of gases. What is the gas flow that the SLE 6000 uses on a high frequency oscillator? Because for conventional, I understand it uses 8 liters per minute, but to deliver high frequency ventilation, how much does SLE 6000, how much gas that it consumes? Number one. And number two question, second question is, sometimes, even though the flow sensor is calibrated and even though the flow sensor is brand new, sometimes there is a discrepancy between the set tidal volume and the delivered tidal volume and the same, it's not, even though the baby's lung compliance is good with adequate peak inspiratory pressure, there is some discrepancy which we had to overcome by adjusting few things. Is there any, we have the latest software update on that. Still, there are fine tuning issues that I have noticed. I just wonder what your thoughts are on.
Okay. Well, thank you to both of you for your glowing references. I thought that was very nice.
Thank you.
You're welcome.
And it's very good to hear that the oxygen is now being used in India. Just a point on that Professor Greenough and her team just published a paper on use of oxygen in King's College. It was published just in the last couple of months. I'm not sure if you've caught sight of that yet, but that was quite a good report. Oh, it was a very good report actually, and they were very excited about using that more broadly across their patients at King's College. The flow of gas question. Well, the fresh gases in conventional modes and HFO, it's always fixed at 8 liters per minute, the fresh gas that rotates around the ventilator. However, gas is also used as the driving force to generate patient pressure in an SLE ventilator rather than using a valve. So the consumption of gas also has to be considered on the what we call the driving side of the ventilator. That's where the exhalation block is. Now, in high frequency oscillation, that gas consumption starts to increase considerably more than it is in conventional ventilation. If it's of use to you, I can send you some details about the actual gas consumption at different settings in high frequency oscillation. If that's of value, and I think from what I can understand from the conversation, that's perhaps what your concern is the amount of gas that's being consumed.
That's right, and we would love to have a bit more detail on the gas consumption, in high frequency oscillation ventilation, to decide, because we are planning to set up a SLE 6000 high frequency oscillator on the transport, and it would be useful for us if we have the exact gas consumption so that we can plan our air cylinders accordingly. In the ambulance. That is one thing, and I have been working. Yeah,
Ram, one small.
Yeah.
Prashant and Martin, can I add some few things here for the Ram's thing, if you don't mind?
I'm happy. Yeah.
Yeah, Ram.
Yeah.
Why probably you might have asked this question: how much air or oxygen together it bleeds? SLE 6000 if we put on HFOV. That is the question probably you might have asked, because that is the thing, how much liter it is bleeding. That is the way you are going to calculate that value, whether it is 10 liter, 8 liter, 15 liter, or 13 liter or 12 liter. According to that liter of bleed, you are going to calculate the nitric oxide. Otherwise, you cannot, because 10 liter, 8 liter into the flow. then only you are going to set the nitric oxide. Because how many liter, whether it is 500, 160 liter, so 180 liter, 230 liter, 340 liter, in the nitric oxide, you should know how much SLE 6000 is bleeding the, what is it, how many liter, whether oxygen and air blending, no, it will blend and it will bleed. That is very important. Otherwise, you cannot set the nitric oxide at 230, 280, 160, 130, because if it is 20 liter, how much? If it is 10 liter, the value is different. 8 liter value is different. 15 liter value is different. So I think so. Take that articles, whatever Martin gives, it is very important, because I am calculating it is 15 liter usually, and I am going. If the delta P goes more than 50, because it never goes more than 36 to 46, usually in this, because it's a powerful ventilator. So 15 liter is more than enough. If the delta P is increasing more than 45 to 50 or 55, then only it will take more than 17, 18, 19 liter. 19 liter. Otherwise, maximum it will take 15 liter. Because there is article in internet about the SLE 6000, how it bleeds. Number one, because that is very important for nitric oxide calculation. Okay, over to Suresh.
Yeah, is there anything else, Ram?
No, and I just wanted to mention, I have been working closely with Steve Dodd as well, and he has been helping us with all the technical queries. So I came to your I came to your company in Croydon last year, and I had a visit at your factory. It was very great. I'm very impressed.
Okay. Now I remember your name from Steve. Yes.
Yeah, that's right. Yeah.
Now I remember. So the other question was about the sensor, a discrepancy in the target. Is it the target and the delivered volume?
Yeah, what happens is, when you set the targeted tidal volume, the delivered tidal volume varies with each breath according to the compliance of the lungs. But sometimes on certain babies, it delivers a very fixed volume. It doesn't move at all. And also the peak inspiratory pressure, the set and the delivered, there is no variation in the peak inspiratory, the delivered peak inspiratory pressure. I don't know whether there is any obstruction to the flow or something that is causing those numbers to be fixed despite variation in lung compliance. So it's just a technical issue. I don't know.
That's an interesting point. I wouldn't expect it would be unusual to see the pressure stabilized, completely stabilized in an infant. It would normally just move around a little bit, even if it's just 1 millibar up and down.
Yeah.
1 or 2 millibars up and down. I'm not sure is the simple answer. I'm not familiar with what that might be, but if you're in contact with Steve, I'll do two things. One is this question I shall share with him about the tidal volume, and the other one is to get this gas consumption information sent directly through to you, if that's okay.
Yeah.
Okay.
And next time when this happens, what I'll do, I'll take a video of the screen and then I will share it with Steve Dodd and see what explanation could be given for my question regarding the tidal volume and the peak inspiratory pressure.
Okay. Yes, that's the best way forward, definitely.
Thank you. Thank you very much.
It sounds unusual.
And just one more point, our postgraduate students are doing they started to do a thesis on oxygeny. So we will have some results soon from India.
Oh, excellent. That's absolutely fantastic.
Thank
That's
you.
great to hear.
Thank you.
Dr. Ram, I just wanted to add one more thing regarding the flow sensors, how to maintain the hygiene of the flow sensors. What we have seen in the initial days, what we used to see that very quickly, clinicians used to come to us saying that the flow sensor is giving wrong data or it's not working properly. And then we did some investigation, and what we found out is that because if you really look at the technology that we use, the wire is getting heated to a very high temperature. And what happens is that if there are any secretions or anything is there, normally what happens, the clinicians actually give some time to get it cooled down, and then they do the cleaning and the process for the sterilization. But what happens during this time, because the wire is really heated to very, very high temperature, all the secretions that's there, that gets burnt, and that create a permanent layer on that wire. And that particular area, gets unused. And over the time, if you run like 3/4 cycles, over a time, a significant portions of the wires will get, will be covered with this. And as a result, the data and others, challenges will come. So what we suggest is that as soon as you stop using the ventilator with the flow sensor, you immediately clean it with the or rinse it with the water, so that while it is hot, you clean the secretion. If you do that, this simple thing, it will ensure that the life of the flow sensors is not in months, it in years. It's really a very good quality flow sensors and gives good data. But this is one basic hygiene that we have seen has made a very significant difference.
Thank you very much. Yes, certainly I agree with you. When we first bought the ventilators about this issue, but after adequate training of the staff nurses and discussion with your team, and Steve Dodd has provided me wonderful guidelines on how to take care of the flow sensors. So following all those instructions, to be honest, so far the flow sensors have been excellent, and we never had any problem over the past 1 year. So we are quite enjoying it.
Mr. Gupta, actually that's one of the areas where your application specialist falls short, because they were not giving adequate training to the users saying how to maintain the flow sensor. We actually went through a failure cycle, and then with Steve's help, and then now our staff are trained on that. The moment they disconnect the ventilator, they put it in water, soak it, and the SOPs that we haven't had any flow sensor failure since then. But I think it should be a point that you insist that your application specialists train the users on how to maintain flow sensors.
Yes, that's a very good point, Dr. Suresh, and thank you for openly talking about that. What we have now incorporated with our, installation process is that in the installation certificate, there has to be one statement saying that the flow sensor cleaning has been explained, and the clinician has accepted that this is the process that they will follow. So I hope I will double check that whether that's being done now, so that to ensure that this point is adequately covered.
Great. Just quickly about your nitric oxide system. It's not very ambulance friendly. Do you know anyone who's using it in an ambulance?
To be honest, no. Martin, do you know anyone, any places it's been used?
No, not offhand. Not offhand, no.
Yeah, but what I can
do you want something more rugged? Is that what you're looking
at? No, I think the power supply is a problem, because we're looking at a different company which has a battery backup and can be connected to the ambulance system. I don't think this has a battery backup.
Right. Okay. No, it keeps the memory going. The battery, it doesn't run the device.
Doesn't run the device. Yeah.
Yeah, but Dr. Suresh, let me tell you one thing. We are also now working with International Biomed, who does this transport incubator system, and I have seen in the picture of the Enosis being used, along with their transport incubator system.
I will see the International Biomed transport system. I don't think it's Enosis. I think it's something else they're using.
It's their own, Chandan. It's their that's a good suggestion. We put it on transport incubators here. Their nitric oxide delivery device.
Yeah.
It's got transport designs in its bloodstream. It's the
So that's all from us. Thank you.
Thank you very much.
Thank you. Thanks both.
If any of our delegates have any question, they can directly unmute and ask our speaker. Dinakar sir, do you have any questions from the audience which has come to you?
Yeah. One question which is there. I think so. It is for Martin. Martin, BiPAP. Then PSV. What is the difference between BiPAP and CPAP with the PSV? Because CPAP, it will give only one PEEP. BiPAP will give even PIP plus PEEP. Then if it is there like that, then why BiPAP is there? Because studies of the BiPAP in neonate are very few, hardly countable 59 or 40 or 39. Why BiPAP is there? How it is better than PSV mode?
That's a good question. Yeah, why is it there? It's there in a ventilator because some people or some clinicians are suitably convinced that it's effective for their patient population. Much like many of the modes on the ventilator, it's an interesting thing. There's I don't know, there's more than 10 modes of ventilation, including the non-invasive modes on the ventilator. And I think most clinicians use maybe 2 or even 3 maximum, and the other ones they never use. So I think there's basically a suite of modes on a 6000 to suit everybody. If that's a reasonable thing to say.
Yeah, I just wanted to add one thing on Martin, like whenever we do any such product development, even in GE, one of the things that we need to see that the big government tenders that come in different other countries. And we have seen that in many countries, because they try to copy from the old specifications, some of those things which are not used very often, those are still there. And in government tender, unless you comply and say that, we comply this, we have this, you become non-compliant. And even if you have a much, much better product, they will not consider you for that. So I have seen that even while we are doing our other products, we actually select some of those features which is hardly being used, or, probably is not going to be used, but still we need to put it in the specifications just to comply with some of those big tenders.
Yes.
Very nice.
Yeah, Martin, there is one more thing. Really, it's a good mode. Always good things will end up in a bad. There is one, just I'm proverb in the medicine. Good things will end up in a bad, or it will go to the corner, like a remdesivir. Okay, later first it was find out, later now it is we are using it for corona. Like that, in your machine, there is called a single limb CPAP. Is it nothing but a variable CPAP?
Single limb CPAP. So yeah. There's two different, or we're familiar with 2 broadly different types of interfaces for CPAP. So there's the single limb CPAP interface, which the infant flow was the original interface in the 1990s.
Yeah.
And that still exists. And then the MediJet later on was the second single limb variable flow CPAP interface. That's exactly what it is. So yeah, that modality is variable flow. Yeah, variable flow CPAP. You got it exactly right.
Yeah. Because compared to the normal CPAP, variable CPAP is superior. But when we ask for the company, they will, for the software, extra money you people will ask us. So that is one thing. Extra funds will ask us. Please pay the money, I will give you. So that is one. See that we are Indians, so Toda, we are Indians. Please try to help us. We are little lower side. Number one. And one more thing, the SLE 6000 till what? Sorry, this one. Sorry, this one I should not ask this question. If we know the proper theory, we should not ask. But however, there is a logic way to think for asking this question. Logic way to think asking this question. SLA 6000 till what weight you people have used? Because company will tell 15 kilo, company will tell 30 kilo. Is it a weightage or is it a disease process? I want to know disease process or according to the weight, like a we have a this thing sensor medics. You know that 300. What is it? I forgotten. 300. I mean A and B is there. You know, like pediatric one and adult one. What is it? HFOV. Like that, you people are also having any for the pediatrics and adults, or SLE 6000 only for the neonate, or you have up to what kilo you have used your machine, or at least in a lab.
Right, it's an excellent question actually. So we publish a range up to 30 kilos on a 6000, and that is well, the science behind that is that the maximum tidal volume that you can set on the device is 300 mils, and at 10 mils per kilo that equates to 30 kilograms. So we've got a a regulatory obligation to state something, and that's what we state, and that's the reason that we state it. The clinical reality is that our products and our brand are predominantly known in neonates and pediatric departments, and probably more so in neonates. So the majority of patients that are ventilated on a 6000 or a 5000 have probably been somewhere between 350 or 400 grams and up to 10, 12, or maybe even as much as about 15 kilograms. My personal experience with using the 5s and the 6s is that in laboratories we have successfully ventilated animal models in excess of 25 kilos. The caveat with that is actually that those animal models had very healthy lungs, albeit perhaps washed out with saline and deficient of surfactant. But they're very healthy lungs and therefore relatively easy lungs to ventilate. So it's a very good question, and it's one that doesn't have a very straight answer, I'm afraid. I think it's fair to say that the safe zone for a 6000 is patients up to about 15 kilograms can comfortably or could be ventilated on high frequency oscillation with an SLE 6000, but maybe more depending on the lung pathology. I hope that helps answer the question, although it doesn't answer it directly.
Yeah. Because even if we will keep it on the big babies, 5 or 6, and if you will increase the delta P in your machine 100 up to 100, it can go. Even if it make it around 60, so almost even 2 ml per kg for 40 kilo, 80 ml will come. So your machine is showing up to 60 kilos or 70. So that is the reason I asked what really you can use it. How many kgs? So that is the question, because if we will, because we bought a adult like a stiff lung and use it up to what kilo, it will give a good volume. Suppose if it is a bigger patient also, we can use HFOV. Conventional we cannot, but HFOV, if it is there, we can use it in your machine compared to your competitor machines. Okay, it's a really nice machine, SLE 6000 from heart. I think so. Ram is using what is the Oxygeny first. So because their owner is very great and very friendly and technical person. More than anything else, he is a doctor, so he is giving. But it's not in our side here. Our side, all people are administrators. So anyhow, we started using for a long time. So very good, Gupta ji. You people are helping. Martin, you have done a great job, really. So over to Prashant.
Dr. Dinkar, I just wanted to add one of my experience, if you allow. So when I was doing the applications on the ventilators, basically for the adult side, I can say I used to explain the BiPAP and CPAP. So BiPAP I used to explain, by definition it's a pressure control of ventilation. Spontaneous breathings are superimposed on that. So the benefit was that we were setting up the backup rates also in a BiPAP, which we cannot set into the CPAP. So here we was setting the IPAP and EPAP, and just if patient is on long duration on the ventilation, so we used to keep on the BiPAP, or on the weaning only CPAP we used to use. This is what I learned.
No. Yeah. See, the same question is, it's all synonymous word. Suppose if you will use the non-invasive ventilator, PSV, that is also same, dear.
Correct.
There also PIP is there, PEP is there.
Correct,
Everything
correct.
is same.
So
that is the reason. Yeah.
Add on backup rate.
Yeah, both are there in PSV also. Non-invasive mode PSV is also there. Then
Correct.
why the word called BiPAP?
Correct, sir.
Yeah. Over to Prashant.
Yeah, thank you, sir. Any of our delegates, if still they have question, they can raise their hands and directly ask our speakers. If not, we have come to the end of the session now. We had a wonderful discussion, and we had a great insight into the ventilator. What are the new things which has been added and how different it is from the previous version. So before I close, I request our NNF State Chapter President, Kotreshi sir, Dr. Kotreshi sir, to speak a few words, and then we will session. Yes, sir.
Yeah, amongst all the series, this is a wonderful session because the ventilation starts up to the 6 years experience, and what is the combination of instruments and other things also. And regarding the expression of nitrous oxide usage, wonderfully being presented by the faculty. And one must appreciate the webinar activities regarding this one. I'm very thankful for the coordinators, Dr. Prashant and Dinkar, for wonderful organization. I'm proud to say that I'm the president, and during my tenure, this is happening in Karnataka. Thank you, one and all.
Thank you, sir. Thank you. So we have come to the end of session. On behalf of NNF Karnataka, a big thank you for Mr. Martin and Mr. Chandan Gupta and the entire team of GenWorks who have coordinated this session. All of them, Anviti and everybody, thank you for coordinating and arranging for such a wonderful session on our NNF platform. Thank you. We will catch up again this coming Sunday with another new exciting topics with a practical approach and helping the audience and the aspiring doctors who wants to make their setup health infrastructure a better place with a cost-effective investment as well. So we will see you again this coming Sunday. Have a great